Hello there. Today we're doing Math 6, Mission 8, Lesson 7, using histograms to answer statistical questions. All right, let's do our warm-up. Here are 4 questions about the population of Alaska. Which question does not belong? Hint, all of them could be argued as they don't belong. So here we go. Number 1. In general, at what age do Alaska residents retire? 2. At what age can Alaskans vote? 3. What is the age difference between the youngest and oldest Alaska resident with a full-time job? 4. Which age group is the largest part of the population? 18 years or younger, 19 to 24 years, 25 to 34 years, 35 to 44 years, 45 to 54 years, 55 to 64 years, or 65 years or older. So if we were talking about last lesson, this would be bins, right? For those histogram groupings. So with number 4, we could say right off the bat, this is the only one that groups data points into bins. See how that works? Number 2, at what age can Alaskans vote? That's going to be the same answer, which means it is not a statistical question. So those are different from the others. Not a question. In general, at what age do Alaskan residents retire? Okay, this is the only question that asks for the center of data, containing the ages at which Alaskan residents retire. So this is asking for the center of data. And number 3, what is the age difference between the youngest and oldest Alaska residents with a full-time job? So this is the only question that asks for the spread of data. Spread, so the youngest and the oldest, right? So you're going to take that oldest age minus that youngest age and you get the spread. All right, let's move on. Activity 1. An earthworm farmer set up several containers of a certain species of earthworms so that he could learn about their lengths. The lengths of the earthworms provide information about their ages. The farmer measured the length of 25 earthworms in one of the containers. Each length was measured in millimeters. Okay, so number 1A, you're going to have to do on your own. Using a ruler, draw a line segment for each length. So grab a ruler. You're looking for 20 millimeters, 40, 60, 80, and 100 millimeters. And you should draw it right off to the side. B, here are the lengths in millimeters of the 25 earthworms. So we have 25 data points. There they are. Complete the table for the lengths of the 25 earthworms. So this one, we're looking for 0 to just less than 20. So 0 to less than 20. So here is 20. So we want everything below that. So that's 1, 2, 3, 4 numbers. 20 millimeters to less than 40 millimeters. So I'm going to look for 40. We don't have 40, but we have 33 and then 41. So we're looking for this and this. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 40 millimeters to less than 60. So again, we're going to start here, go up, and then we're looking for 60. Here's 60, so we want to go just shy of that because we do not include 60. So that's 1, 2, 3, 4, 5, 6. 60 to less than 80. So we don't have 80, but this is right here. So we have 2. And then 80 to less than 100 millimeters, and we only have 1 remaining data point left. Use the grid and the information in the table to draw a histogram for the worm length data. Be sure to label the axes of your histogram. All right, so the 0 to 100 Is that the number of earthworms or their length? Well, our length says 0 to 100, so I would say this is the length. Woo, so sorry. Sometimes technology doesn't like to work. Here we are. All right, so this would be length, and it's in millimeters, so we're going to put that. And then this would be earthworms. So number of earthworms. All right. So from 0 to 20, we have 4. So we're going to go like this. 4 is 0 to 20. Then we have 20 to 40, which is 12. Okay. 40 to 60 is 6. $60 to just less than 80 is 2. And 80 to just less than 100 is 1. All right, there's our histogram. Based on the histogram, what is the typical length for these 25 earthworms? Now remember, we are looking for the center of our data. So the center of our data, this is 4, 12, and we had 25. So this is 12, 13, 14, 15, 16. These two data points are 16 of our 25 data points. So I would say that our center is between 20 to 40. Okay, millimeters. So you could do it by a bin. So this would be a bin, right? A group. Or you could try and take a guess in there, right? For instance, like if you said 30 or 35 millimeters. Any of these would be acceptable answers. Write 1 to 2 sentences to describe the spread of the data. Do most of the worms have a length that is close to your estimate of a typical length, or are they very different in lengths? All right, so the spread is your lowest length, or your greatest length minus your lowest length, right? So most of the worms appear to be shorter than my estimate of the typical value, but they are all pretty close to it. There are worms that are longer than my estimate, but not as many. Okay? So most worms appear to be shorter. Right? Because if we're looking at 35, that's somewhere between, that's like here, right? 35. And a lot of the worms are less than 35. But the majority of them, right, like here, the majority of them are grouped together, right? let's go on to activity 2. The earthworm farmer measured the length of 25 earthworms. So again, 25 is our data points from a different container. Each length was measured in millimeters. Here are the lengths in millimeters of the 25 earthworms. Complete the stem plot. Okay, we have not learned what a stem plot is, so I'm going to teach that to you now. Okay, so a stem plot, I'm going to scroll back up here and we are going to write these notes here. Stem plot. All right, a stem plot is a way of displaying numerical data. Okay, so it's just like a histogram, a dot plot, it's a way to display data. All right, a stem plot, or you can hear it called a stem and leaf plot, is a table where each data value is indicated by writing the first digit on the left, that's what we call the stem, and the last digits on the right, that's what we call the leaf. Each stem is written only once and shared by all data values with the same first digit. So it's going to make more sense when I show it to you, but you have a stem, which is the first digit of the number. And then you have a leaf, which are the remaining digits of the number, the last digits. Okay, so for example, this is a stem and leaf plot. It looks like a table. We have the stem and we have the leaf. So if I have a data of 23, 26, 29, 31, 33, 34, 38, my stem and leaf is going to look like this. I'm going to take the first digit of the number. So in 23, that would be 2. So I'd write 2. And then my leaf is 3. That makes 23. But I also have 26, and it has the same first number. So I simply write the 6 in the leaf. And then my next one is 29, has the same first number, 2. So I just write the 9 under the leaf section. So now I see I have the number 23, 26, and 29. 23, 26, 29. Same with the 30 numbers. So I have the number 31. I write the 3 here under the stem and the 1 under the leaf. Then we have 33. So again, I just write this 3 under leaf. Then for 34, I write the 4 under the leaf. And for 38, I write the 8 under the leaf. So I know I have 31, 33, 34, and 38. That is a stem plot. All right, so here we go. It's asking us to complete a stem and leaf plot. So they've done the first one for us. You can see here 19 is done. The 1 is written under the stem and the 9 is written in the leaf. Now, we don't have any more 1 stems, so we're going to go to 2s, where we have 27. So the 2 is written for us, and we're just going to write the 7. Then we have 35. So again, the 3 is written. We write the 5. 40. So we write the 0 because the 4 is already there. 44. 44. 46. 49. Then we have 55. 57. 61, 64, 65, 65, so we have 2 of those, 68, 72, 75, another 75, another 75, and another 75, and a 77, and a 79. And we have an 80, an 88, a 92, and a 97. We have now completed our stem and leaf plot. So, based on the stem plot, what is a typical length? Remember, that's the center for these 25 earthworms. Okay, so if we're going to do a bin, right, like a grouping, I would say it's between 60 and 80, right? Because that's where the majority of our numbers are. So if we're going to do a bin, right, I would say between 60 and 80 millimeters. If we want to get more specific, I would say somewhere around, let me change colors, somewhere probably around here, right? So 72, 75, so I'd maybe say 70 millimeters, 75 millimeters. Any of those will work. So write 1 to 2 sentences to describe the spread of the data. So I think the mode of 75 is a good estimate for the center of the data, right? Because this one has the most numbers, 75 is the most occurring number. Over half of the worms have a length within 10 millimeters of my 75 estimate. So that's a pretty good cluster. So that's similar to the spread shown in the histogram for earlier. So I would say that over half the worms have a length within 10 millimeters of 75. So that's why I think the spread is that. Okay. All right, activity 3. Professional basketball players tend to be taller than professional baseball players. So we're talking about basketball players and baseball players. Here are 2 histograms that show height distributions of 50 male professional baseball players and 50 male professional basketball players. So that's our data points. Decide which histogram shows the height of baseball players and which shows the height of basketball players. Be prepared to explain your reasoning. Well, let's look. They both go from 66 to 90. 66 to 90 inches. But it says basketball players are taller, usually taller than baseball players. So if I'm looking for my center, I'm going to say my center is somewhere around here, around 80 on this one. Let's look here. So this one's 20, this one's 8, 4, probably 1. So I would say the center is probably somewhere here, maybe 74. So the majority of the players in A are taller. And if I know basketball players are taller, I would say this one's basketball and this one's baseball. So histogram A shows the basketball players, histogram B shows the baseball players. 2, write 2 to 3 sentences that describe the distribution of the height of the basketball players. Comment on the center and the spread of the data. So the basketball players' data distribution is centered around 80 inches. So there are 2 that down here that are smaller and 2 that are taller than, I would say, the cluster. So most players are within a couple inches of 80, right? So let's write that down. Okay. Basketball players' data distribution is centered around 80. inches. Okay? Now, if we're talking, so we've talked about the center, let's talk about the spread. We have 2 players shorter and 2 players taller than our cluster, than our average. Oh, not average. Let's call it typical because that's the word they like to use. Our typical distribution. All right, write 2 to 3 sentences that describe the distribution of the heights of the baseball players. Comment on the center and the spread. So now we're looking at histogram B. Histogram B. So the baseball players' data distribution is centered around, I said 74, right? So distribution is centered around 74 inches, right? So, and then with our spread, if we do 74, they're pretty much within 6 to 8 inches on either side of that, right? So we can say that all players fall within 8 inches of the center. So that's going to be our spread. Okay? All right, so we've talked about a lot today. We've talked about histograms, and we've talked about and analyzed histograms. We've talked about center, we've talked about spread, and we've got a new term, which is our stem plot, or our stem and leaf plot. Okay? So please review the lesson summary if you need a little more help. Have a good day.